Hey Rebels, Bond here from Rebel Off-Road. We're down here at Currie Enterprises today. Last week we were down at S-Pod, and we're going to go inside, meet the Curries, and talk about some of the heaviest duty upgrades you can do to your vehicles. Well, look who's here to see us. It's John Currie, Currie Enterprises. How are we doing, John?
Good.
Thanks for having us down here today. We'd like to learn a little bit more about what Currie Enterprises is, the processes you guys put in place in building those heavy-duty components in your rear ends, and looking forward to a fantastic day with you.
Well, let's go take a look around then.
So here we are, we're at Currie Enterprises, and we're inside their designated sound studio. We're going to be talking with John today about some of the components that are actually on my particular vehicle. I run Currie's parts, I run their axles, their anti-rocks, they build fantastic components, I even run their Johnny joints. So John, tell us a little bit about some of the components that Currie Enterprises offers.
Well, the main thing Currie is known for is rear ends. And so on your Jeep here, you got our Rock Jock 60 in the front and our new Rock Jock 70 in the back. And also on your Dana 70, you've got the full floating system. Full floating system allows you to run, the axle only turns the wheel. The weight of the vehicle is actually carried by the spindle in the hub. So similar to what a trophy truck would run, or a 3/4 ton or 1 ton truck would run on the road.
And why is that so different from a semi-floater? What are the major differences between the two?
The semi-floating axle, the bearing goes right on the axle and the wheel connects directly to the axle. So the weight of the vehicle is carried by the axle. On these vehicles, because they're so big and heavy, if you get a lot of weight in the vehicle and you are out rock crawling or something and you take a hard hit to the left or the right, it could bend that axle flange. The advantage to the full float is there's a spindle which the axle goes through. The spindle, actually the bearings for the wheel are carried on that spindle and the wheel rotates on the hub. So the axle, on this one, I think it's 40 spline, only has to turn the wheel. It's not carrying any of the weight.
Can you tell us the benefits over a manual locking hub versus running a slug, which is one that you cannot unlock, on a vehicle that's going to be driven on the street as well as off-road?
The biggest advantage of a manual locking hub is you're getting rid of all that parasitic drag that you'd have on your drivetrain. If this hub is locked in, you're turning the front axles, the ring and pinion, all those bearings, the front drive shaft, all the way into the transfer case. When I unlock this hub, you get rid of all that drag. Nothing turns, only the wheel is turning, it's not turning anything. So that's one of the big advantages of having a locking hub over a drive flange or a non-locking hub. Let's say you break a drive shaft or you bend a drive shaft. Well, when I unlock this hub, none of that stuff's going to turn, so that you're going to be able to drive it home in two-wheel drive without an issue. Where if that was a stock JK and you bent a front drive shaft, in order to be able to drive that vehicle home, you'd probably have to take the front drive shaft out because it would be vibrating or whatever.
So we've moved to the front of the vehicle. On my particular vehicle, we run a Rock Jock 60. Rebel does specific widths, and the reason we do these widths is so that we get clearance for different components. A lot of the times we run coilovers on the vehicles. They give a lot more droop and a lot more wheel travel running a coilover, and that means when the tire is getting at full stuff, we want to make sure it's going to clear all the other components. Well, mine gets used pretty heavily, and believe it or not, we actually did give it a cleaning before we came down here. But yes, you can see on the front it does take a pounding. As I said, I've had this axle in here since 2008. It's holding up great, but this vehicle gets used all over. It's used up in Moab, it's used at the Hammers, it's used the whole way down in Florida, Jeep Beach and Texas and all across the country. It's fun shipping it around, it's fun driving it everywhere we go and using all the harder obstacles. Which is actually one of the reasons why I run such a heavy-duty front end.
The Rock Jock, we developed it years ago, and the advantage of the Rock Jock is actually the angle of the front diff cover. We've rotated this angle back quite a bit. I think it's at like 60 degrees, and what that does, it takes this lip right here on the front cover and rotates it up. The advantage is we're gaining almost an inch of ground clearance underneath the ring gear. Where before, when this cover is rotated down here, it would be down here like this. That's really the signature of a rock jock front end.
Now I noticed also on the rock jock, you have a skid plate riding underneath.
Right.
Tell us about the skid plate. What's it made up out of? How does it handle the rocks?
The skid plate is AR400. And if you've ever been out in the rocks with standard cast iron differentials, when you actually hit a rock on the iron itself, it's actually really sticky. It wants to stick on there. And the whole thing about we call this the jock strap, is that this is a hard material. This is actually what they use in the buckets on tractors. It's a pre-heat treated material. And that jock strap goes on there, so when you do get on a rock, it'll actually slide over the rock. Gives you a good ramp, and it's actually harder, so it slides on the rock easier than...
One of the benefits of running the rock jocks is the fact that you are going to a larger brake on the front of your JK.
Right.
One of the biggest complaints we have with customers is, of course, on their factory-style axles, Dana 30s, Dana 44s, is when they're running big tires and they're driving on the street and they're trying to stop, or if they're trying to ease off of some rocks. Mm-hmm. Tell us about the size of the brakes. You've gone from the 11.5-inch rotors up to I think it's 13.5-inch.
Yeah, it's up to a 13-inch rotor. We actually it's the rotor off of the front of a Dodge pickup, I believe it is. When you step up to 1 ton, you go from, I believe it's around a 12-inch rotor up to a 13-inch rotor, so that automatically is going to give you more stopping power. You have more leverage on the wheel at that point. And that's just automatic when you go to the 1 ton.
Let's talk a little bit about what this particular unit is, and this here's a Dana 70. I've run the Dana 60 for many, many, many years. Now we've upgraded this one to a Dana 70. Can you tell us about the Dana 70 and what's involved in making a Dana 70, and the fact that it is a rock jock which is tilted?
Yeah. Well, we needed something that was a little bit stronger than a Dana 60. And we wanted to still have a high pinion rim, because a lot of the Jeepers that we're building stuff for, they are still using their Jeeps in the rocks quite a bit. So we wanted something that was really rock friendly as far as getting that drive shaft up and out of the rocks. The difference, the Dana 70 has a 10 5/8 ring gear, and the Dana 60, the standard ring gear, is a 9 3/4. Another thing we done on the Dana 70 rock jock, we've actually beefed up the housing. It's actually got beefier ribs in it. You see these things are over a 1/2 inch wide, where the 60 has a little thinner rib to it. On the Dana 60, the standard tube size is 3-inch, but on the Dana 70 comes with a 3.5-inch tube. So just in that alone, a 3.5-inch tube compared to a 3-inch tube is probably over twice as strong as a 3-inch tube. Then also in the Dana 70, it's available in 35 spline, but it's also available in 40 spline.
One of the great things also about the Dana 70 is we can have them set up. They're a specific width that we have them made, but we can have them already set up with all of the correct bracketry on there for either your TJ or for your JK. They set them up in jigs. It's ready to go. The correct pinion angle's already set. And in addition to that, for those of you who want to get more custom, we can actually put a truss on there. John, I want to say thank you for having us down to Currie Enterprises. Let's go have a look at your manufacturing facility, see how the axles are actually built.
Awesome, let's go look.
Great.
The first place we start is here. The first thing I'm going to build for that we're in is actually the tubes that go in the housing. So Shorty here will get an order. The first thing they're going to do is cut the tubes, and that's what he's doing here in that saw. Then the tubes go to the tube turner over here, Tony. He's going to machine those tubes to fit into the housing. So he's going to face them, turn the ODs on them so they can press them together. Depending on what it needs, like this is for a front housing, they'll put a seal surface in it. This is where they press the tubes into the housing. They're doing some aluminum 9-inch housings in there right now. On the aluminum ones, all we do is heat them up and drop the tube in, because the aluminum expands at a greater rate than cast iron. On the iron ones, we heat them up there just to put a little heat in them, so they just will accept the tube easier, so it goes in a little bit easier. Now we're in our welding shop, basically. Each station here usually has their own responsibilities. What Art is working on here, this is a 9-inch front end. Looks like it's going to go on a TJ. It's got the TJ spring buckets, fixtures to hold the spring buckets on, the bump stops, the lower control arm mounts, and then when he gets into the upper mounts, there'll be a top part of the fixture that bolts on, or a part of it. Depending on what it is, there's different fixtures for each one. This is one of our new Dana 44 center sections here. Notice how it's got the top mount already cast in it. Looks like he's setting it up for what, a TJ?
TJ?
Yeah, TJ. So he's gonna set it all up to jig the knuckle on, and then put all the bracketry on it. He'll do all that here. Once the housings come out of the weld shop, they got to be clean to get all the debris out of them. We have everything from steel braiding machines to high pressure washing machines. So you see here he's lifting this housing up. It's going to go in the high pressure washer. That's just to ensure that everything is clean. There's nothing inside of it. You can see these big paddles in here. Yep. They turn and shoot steel shot up, and that's what cleans the part. So now we're going to enter the axle department. Around the outside of the axle department is all the axle inventory, all the different axles that we keep in stock down here. They usually will cut the axle to length, and then they'll put the axle in the engine lathe, face the end of it, put a chamfer on it, and recenter it. Once that's done, then the axle is brought over here to one of these splining machines. And what this machine does, it actually drills. Right now they've got it set up. There's actually a couple things that it does. The main thing we use it for is actually drilling the axle. So we'll go in here, this thing will turn around and drills the bolt pattern in the axle. For all the Dana style rear ends, 12-bolt rear ends, they're all going to be assembled in these two benches. So these housings here are all waiting to be assembled. These are all jobs they're working on right now. Once the rear end is completely assembled, put together, then it goes right into shipping. The manufacturing area, everything that they're building is already sold. What we're doing, we're building inventory up here. So if Rebel Off-Road wants to order some Johnny joints, we pull them off the shelf and ship them. This is kind of a staging area here right now, but this is going to turn into more warehouse here shortly. That building down there is like right under 20,000 square feet, and this building's 22,000 square feet. This is our R&D area. This is where if we're working on a new product for a vehicle, we've got actually 4 lifts in here. Full floating hub.
Gotcha.
That's what that hub starts as. That's what it started like. That's after it came back from plating, and we put black zinc on it to make it look nice. And then you can see the amount of work. See, there's the back of it. It's like a real hard plastic. The reason we use this, it doesn't squeak. So it doesn't matter if you oil it or not. Like a urethane bushing will squeak, plus it has like a lot of give in it, where this is really hard and it doesn't squeak. And these will pretty much last forever. It takes, I think a little over 2 minutes to machine one complete. And you can see it's going to push the bar out, bring a stop in. That's it. They actually go from here to be heat treated.
John, thank you for having us down here. It's great being able to see how axles are produced from the raw materials the whole way through to the axles that we actually install in customers' vehicles. Look forward to seeing you out on the trail. Thanks a million.
Well, I appreciate you guys coming down and spending the day with us.
Thanks, John.
All right, see you later.
Curries and talk about some of the heavier. Let's try that again. So here we are. We're inside of Currie Enterprises.
Yeah.
All right. So you're still recording?
Yep. So, and it
Okay. So now we've moved to the back of the vehicle where we're going to talk about. So now we've.
Oh. We need a little light out there that says
on air.
Electric vehicles.
Golf carts.
Yeah.
They do it for
industrial applications.
So this here's a Dana 70 on my particular. Let's try that again. What is really the differences between, let's say, a Dana 44 and a Dana 70? A lot of people say, hey, it's just a bunch more Danas.
You know, your thing
I gotta tell you, my jock straps work.
for it. In this, and let me delete our.
John, I want to say thank you for having us down to Currie Enterprises and taking the time to spend. Let's try that again. John, I want to say thank you for having us down to Currie.
That's me. Sorry.